Hello, and welcome to Metropolitan Community College's presentation on connecting to the Nexus, exploring the industrial Internet of Things. This grant is funded through NSF. Our NEXUS team include Lindsay Gibbs, who is our project director, Karen Wagner, who is the instructional designer, and myself, Mike Gerke, who is our lead instructor. Our grant deliverables include instructional resources, equipment kits, and implementation support. With our instructional resources, we have provided lesson plans, aligned those plans to various standards. We have assessments available, as well as videos for the lessons. Everything is also available on a Canvas course for your review. Our equipment kits include the sensors and the gateway, software in order to collect and show the data, as well as lists of what else is required for the experiments to take place. For our implementation support, we are offering train the trainers, exploratory workshops, and we have multiple websites and portals. Currently, with the COVID-19 situation, our exploratory workshops are being handled remotely and asynchronously. However, we are hoping to open up in-person trainings towards the end of the year, depending on how the virus situation develops. All of this comes together so we can teach our students the basics of the industrial Internet of Things. We have developed this into 4 different modules, including lean production, just-in-time inventory management, predictive maintenance, and a final one where students prototype a solution by themselves. The entire module support follows the engineering design process. So what the industrial Internet of Things is, from the Internet of Things, including smart speakers, including the Amazon Alexa and Google Home, to devices such as light bulbs and switches that are controlled via the internet. The industrial Internet of Things takes these sensors and devices and puts them into an industrial setting. So these are typically found in critical facilities, manufacturing plants, and IT facilities. The data is monitored to make predictions and to drive smart decision making. Typically, all of the data is originally sent to the cloud, where it can be analyzed to not take up so much computing power locally. This data is typically sent back to a central monitoring station, which allows for a smaller amount of individuals to monitor a larger amount of facility. Our grant equipment can be seen here. With a kit, you would receive a gateway, 3 temperature sensors, 3 contact sensors, and 3 shock sensors. It also comes with a series of Cat5 cables, power supplies, and fan weights for the various modules. These kits are loaned out, but they're also available for purchase through our corporate partner. On this screen, you'll see what our standard data collection looks like in our dashboard. Students learn how to pull data from the sensors and push them to a dashboard where it can be interpreted and seen easily. The raw data will come in from the sensor, and then they can do a various calculations on that data and display it also as a trend. You'll see here that there are different colors ranging from different thresholds that have been reached within the data. Students learn what thresholds mean and how to analyze and interpret the data and set their own thresholds, which can result in sending text messages or emails to their personal devices if they ever run out of spec. Like I said before, our modules include predictive maintenance. In this module, we use temperature to explore the dashboard and basic calculations. In our lean manufacturing module, students monitor vibration, and they'll determine correlations to mask placement on a fan. And our final scripted module is just-in-time inventory, where students use a contact switch and they monitor product being produced. In our first module, you can see here, students will need a hairdryer or another heat source. These are not provided in the kit. However, they can be found relatively cheaply on Amazon or Walmart or any place else where you might find a hairdryer. Students will learn in this module how to calculate the data and how to work in a team. This gets them the very basics of understanding what the sensors are doing and how they're collecting the information, how to wire up the whole thing to the wall, and then collect basic data. Our second module takes them a little further, where they're introduced to different sensor types. They will monitor weight distributions of fan weights around fan blades, and they start to create a dashboard from a blank dashboard. You'll see here on the right that we have all of our modules written out in such a way that students can follow through like a basic laboratory exercise, and they will get all the information that they need. Our final scripted module, just-in-time inventory, and by scripted, we typically mean that the solution is known by the instructor. The students are challenged to the full range of knowledge that they're taught in the workshop, in which this one comes the closest to an actual scenario that they may experience. This module utilizes the contact sensor and uses it in a way that it was not designed for. We find that to be important as it gets the students to start thinking outside of the box and how to correlate different physical phenomena using sensors in non-traditional ways. Our final module in rapid prototypings, we give the students a series of scenarios. They engage in one of them or multiple, depending on time. They design and build an IIoT solution utilizing the loan technology. And then finally, they'll collect sample data and discuss it. The nice thing about this module is that there is no right and wrong answer. There's only a large scenario with a whole lot of information based on real world problems that has happened in our Omaha area. And students have to come up with their solution that they think will most effectively address the problem. The issue that we have run across in this module is that we do not have access to all of this equipment for students to implement their IIoT solution onto an actual factory floor in order to test data. So it is a very creative workaround that students and instructors will have to do in order for any sample data to be collected for the discussion. All of the equipment is available for loaning. We, at this moment, have 4 available. However, power over Ethernet is a requirement. We have found that to be a challenge, as most home routers do not have that capability. However, if you are back on campus or back in your high school setting, then that shouldn't be an issue for you. The one thing that is necessary is that our gateway and sensors have to be able to connect over the internet and shoot data out. So sometimes there's firewall issues. However, we'll be able to help with that implementation if necessary. If you would prefer, you can purchase your own kits from our vendor if you want one as by yourself. Our current loan time is 2 to 4 weeks, depending on when you need it. We ship it to you, you ship it back to us. Our kit comes with the gateway, 12 sensors, power and Ethernet, and curriculum. If you have any questions, feel free to stop by our website, send us an email, or call us on the phone. We're available Monday through Friday. Finally, I would like to thank you guys for sitting through our presentation on the Industrial Internet of Things. Again, we're funded through NSF, and we are part of Metropolitan Community College in Omaha, Nebraska.